today, and this is where things really start to get into it. You've got to be able to work with what we're doing today. This is quadratics. This isn't bad if you follow the programs. The hard part's going to be going backwards, factoring stuff, much harder than we were doing the other day. But the better you are at today, the easier that's going to be. Okay, so what we're doing today is multiplying binomials. I'm going to show you two different methods for doing this. First one is FOIL. FOIL. First terms, outer terms, inner terms, last terms. F-O-I-L. FOIL. On your classwork, it will say distribute.
Put your headphones and your phone away.
August. You got booted yesterday. You want to get booted again today?
Just
Don't
put
argue
it
back.
away.
Just do it. So, when you're foiling, the directions will stay distributes on your classwork, but what they really mean is FOIL. And FOIL is actually really easy to do. Okay? Okay, foiling. It's really easy. First terms. What that means is you're going to take the first term in each binomial, those two, and multiply them together. So I have x times x. Gives me x squared. Oh, the outer terms. The ones on the outside. X times 5 gives me 5x. Then you do your inner terms. 2 times x gives you 2x. And then you do your last terms in each one. 2 times 5 gives you 10. So I've multiplied everything. Everything's been multiplied. I've done all my multiplying I could do. Now you combine like terms. Okay.
Take this too.
Okay, so
Wait, how am I supposed to get my lesson on it?
we've done all the multiplying. Our answer's not yet finished. What we have to do is combine up like terms. Usually, but not always, usually like terms are only those two in the center. Almost always. Not every time, but almost always those are the like terms in the center. So I have x squared here, and then I have 5x plus 2x, gives me 7x plus 10. Piece of cake. First, outside, inside, last. You multiply the first term in each one, you multiply the outside terms, you multiply the inside terms, you multiply the last terms. Okay? FOIL works great if you have two binomials. There is another way to multiply them that will work with any type of polynomial, not just binomials like this. That's called the boxes method. Okay, where you have a box. You're basically setting up a multiplication chart. So I have a binomial, 2 terms, a binomial, 2 terms. So I have a 2 by 2.
Do you have to do both of them? Or
No, it could be either one.
Okay.
Whichever one works for you. And I've had students that they prefer one, some students prefer the other. These are both good methods that work. Good question, though. So, 2 terms, 2 terms. I have a 2 by 2 box. Here's what you do. You take one of the binomials. Either one, it doesn't matter. And you put it on one side. I have x plus 2, so I have x and 2. And then you take the other one and you write it along the other edge. X plus 5. If it's a minus in between, make sure to put the negative on there. So I've written it out. Now you fill it in like a multiplication chart. X times x is x squared. X times 2 is 2x. X times 5 is 5x. And then 5 times 2 is 10. Just like a multiplication chart. You're multiplying through to get the boxes filled in like a multiplication chart. And here's what's really cool. I still have to combine up like terms and rewrite it. But 90% of the time, your like terms are on the diagonal. If you have a diagonal, your like terms are going to be on the diagonal. So when I put this out and finish it up, I have x squared. 5x plus 2x gives me 7x. And then I have plus 10. Two ways of doing the same thing. Some students prefer one way, some students prefer the other. I really, as long as you're getting the correct answer, I don't care which way you choose. Okay, like I said, I've had both. I had a lot of students last year that liked the box and used it for almost everything. I had a handful of students that liked FOIL. Usually more kids like this than that. I don't really care. Okay? Questions on that? This is a much more important skill than you think, because what we're going to be doing later is going to be much harder, is going from here to there. We're going to be undoing. That's much more difficult. The better you are at multiplying it out, the easier the factoring is going to be. The better off you are at doing today's stuff. You get this down and understand it and do it well. When we go backwards, it's so much easier when you do that. Okay? So, here we go. It says using the distributive property. This is the directions you'll have in your notes, and this will be what they mean here is to FOIL. When you see distributive, think, ooh, FOIL. Okay? 2x times 3x. What's 2x times 3x? 6x squared, because I have x times x gives me x squared. Remember, x1 is changed with multiplying, but not with adding or subtracting. So that's my first terms. Then I do the outer terms, 2x times negative 7. Negative 14x. And then I do my inner terms, 4 times 3x plus 12x. And then I do my last terms, 4 times negative 7. Always the same kid every time. Okay. Now I need to combine up like terms. I've done the multiplying. Everything's been multiplied. Now I do my combine up like terms. My like terms are these two here, so I have 6x squared. Negative 14 plus 12. Negative 2x. And then I have my minus 28 here at the end. And that's my answer. Okay. Question. First out, in, last. First terms, outside terms, inside terms, last terms. We'll cover everything. And honestly, drawing the little lines like this really do help you keep track of what you're doing. Okay, using boxes. Same idea. I have two terms and two terms. So I set up a 2x2 box. I have x minus 3. Doesn't matter which side the x minus 3 goes on. No, it doesn't matter. You can do it on either one. X minus 3. And then I have 4x minus 5. 4x minus 5. That's your setup. And then once again, fill it in like a multiplication chart. 4x times x gives me 4x squared. 4x times negative 3. 4 times negative 3 is negative 12 with an x on there. And then I fill in the bottom row, x times negative 5, that's negative 5x. And negative 5 times negative 3 gives me positive 15. I basically did the inner out. I did the FOIL method, just organized a different way. The first terms, the outside terms, inside terms, and the last terms gives me what I have. And then I combine up like terms. These two are in the center here. I have 4x squared. Negative 5, negative 12 gives me negative 17x plus 15.
Cameron. We don't ask you guys to do a lot. The least you can do is unplug and put your phones away during lunch.
Set up the box on the next one. Okay. It does not matter which side the n minus 6 goes on and which side the 4n plus 7, n minus 6, 4n, and then 7. If you don't have it exactly the same way I do, the only difference will be these two diagonal ones will be switched, but your final answer will be the same. Okay? Fill in the squares. If you have not already done so, take a moment to fill in the squares. So you get 4n squared minus 24n, 7n, and negative 42. And once again, if you have them in different on the sides, just the middles, the two diagonals will be switched, but the numbers do the same. And now I combine up like terms. I have 4n squared. My diagonals are the same. Negative 24 plus 7 gives me negative 17n minus 42. I'll be honest, I usually use FOIL if I have a binomial, if I have something like this. If I have two terms and two terms, I usually use the FOIL method, but box works good. I like box method when you get two problems like this one. You can't use FOIL if you have 2 terms and 3 terms, or 3 terms and 3 terms, or 5 terms and 10 terms. If you've got more than 2 terms in either one of them, or both, you can't FOIL. FOIL only works if you have 2 binomials. I get something like this, you have to set up a box. And I've done this in classes where I've had great big boxes that take up the whole freaking page. It works really good. How many terms do I have in the first one? How many do I have in the second one? 3. So I'm going to make a box that's 2 by 3. This is really good to keep your work organized. That's what the box does, is it keeps your work organized. Now, it does matter which one goes on which side, obviously, on this one here. The 2 terms, 2x minus 7, go on that side, where the 2 sides are. And the 3 terms, 3x squared, x minus 5, go on the side with three terms on it. And then you fill it in exactly the same way. It's still fill it in like a multiplication chart. I have 2x times 3x squared. 6x cubed. 2 times 3 is 6. X times x squared is x cubed. 2x times x, 2x squared. 2x times negative 5, negative 10x. And then I fill in the bottom row the same way. Negative 7 times 3x squared gives me negative 21x squared. Negative 7 times x, negative 7x. Negative 7 times negative 5 is positive 35. A lot of you had problems the other day with your negatives and positives. You're distributing. And guess what? The like terms are still on the diagonals. My x squareds are there. My x's are there. Okay. So I've got 6x cubed. So that takes care of my x cubed. I don't have any other x cubed. My x squareds are on the diagonal, so I combine them up. 2x squared, negative 21x squared. Gives me negative 19x squared. Negative 7x, negative 10x. Negative 17x. Oh, you got one wrong. And then I get plus 35. What was that? Like I said, you can't FOIL if you have more than 2 terms. Box method works great. And I've done ones literally in classes where I've, fill in all the page with one great big giant box. So they got like 7 terms and 8 terms. And what's really cool is on the diagonals, I may have like 10 terms that are like terms, but they're all on a diagonal. So it keeps it nice and organized. I like that. Then it would just be a 3x3 box, and your diagonals would still be, and you'd have another set of boxes here, so you'd have 3 on a diagonal here that are like terms, because they're still all like terms. No, FOIL only works with 2x2. Will not work with anything other than 2x2. That's the only drawback to FOIL, is it only works with 2x2s. Okay.
You're fine.
Okay,